What if the toilet, a piece of technology that hasn't fundamentally changed in over a century, was quietly being replaced right now? Not by a smarter version of the same idea, but by something that needs no water, no sewer pipes, and no plumbing at all. It started as a solution for astronauts stranded in space. Today, it's already running in tens of thousands of homes on Earth, and the story of how it got here is stranger and more American than you'd expect. To understand why this invention matters, you first have to understand a problem most people never think about. Every time you flush, you send several liters of clean, drinkable water straight into a sewer. Multiply that by billions of flushes a day, and you start to see a hidden strain on one of the planet's most limited resources. For most of the developed world, that's an invisible cost, buried underground in pipes we never see. But for engineers working on a very different kind of bathroom problem, it was impossible to ignore. Because in space, there is no sewer system. There's no gravity to pull waste away, and there's absolutely no water to spare. This is the environment where our story actually begins. An inventor named Diana Youssef was working on sanitation systems designed for astronauts' technology, built for the extreme conditions of spaceflight. Her challenge wasn't comfort or convenience. It was survival engineering. How do you safely manage human waste with zero water and zero infrastructure? Every design decision had to account for weightlessness, sealed environments, and systems that could never fail mid-mission. It's the kind of engineering problem most plumbers never have to think about, but it forced Youssef to question an assumption almost everyone else took for granted. What if water wasn't actually necessary to make a toilet work at all? What she didn't expect was that the answer to a space problem was also the answer to a problem affecting billions of people back on Earth, because it turns out roughly 2.5 billion people worldwide still lack access to safe, modern sanitation. No sewer lines, no treatment plants, no reliable plumbing. For these communities, the absence of sanitation isn't an inconvenience. It's a daily health risk. Youssef realized the same waterless approach built for astronauts could work in places with no infrastructure at all. And that realization became the seed of an invention now called the iThrone. So how does a toilet work? Without water, without flushing, and without a single pipe connected to it? At its core, the iThrone is built around a simple but clever engineering principle: separate the waste and process it on the spot. Instead of using water to carry waste away to a distant treatment plant, the system contains and treats it directly inside the unit itself. Specially designed materials and internal processes work to break down waste safely without relying on a city-wide sewer network. The unit is also engineered with passive air circulation, designed to prevent the odors people usually associate with waterless systems. No flush, no pipes, no smell. At least that's the goal researchers and engineers have been chasing for years. It sounds almost too simple, which is exactly why it took so long for anyone to build it successfully. For over a century, plumbing engineers assumed the toilet's basic model was untouchable. Water in, waste out, and an underground network doing the invisible work. Rebuilding it from scratch meant challenging one of the most standardized systems in modern infrastructure. Every hospital, every home, every city code was built around the assumption that water would always be part of the equation. Changing that assumption meant more than just building a new device. It meant convincing an entire industry to rethink its fundamentals. But once the NASA-inspired design proved it could work off-grid, something changed. The technology stopped being a niche space experiment and started being a real deployable product. This is where the story shifts from theory to reality. The iThrone hasn't stayed in a lab or a prototype stage. It's already been deployed in real households in real conditions across multiple countries. Reports indicate the system has reached an estimated 20,000 households, including installations in Uganda, Panama, and right here in the United States. That number alone raises an obvious question. Why would anyone in America, where sewer systems already exist, choose a toilet like this? The answer lies in a part of the country most people don't think about when they picture modern plumbing. Millions of American homes, especially in rural areas, still rely on aging septic systems or lack reliable sewer access altogether. For these communities, a self-contained waterless option isn't a luxury, it could be a practical necessity. Some homeowners have reported installing these systems specifically because septic repairs or new sewer connections were simply too expensive. And that's the moment this story becomes bigger than one clever invention. Because engineers at Georgia Tech have been working on a parallel idea, backed by a very different but very serious authority, the Bill and Melinda Gates Foundation. Their program, aimed at reinventing sanitation entirely, has funded a multi-million-dollar effort to build the next generation of toilets from the ground up. Their goal isn't just rural homes, it's cities. Researchers involved in the project have pointed to major U.S. cities where sewer infrastructure is aging and expensive to replace. One researcher put it simply, replacing all of that underground infrastructure at the end of its life could be far too costly to justify. In other words, waterless and self-contained systems aren't just for developing regions anymore. They could become a serious option for developed cities facing their own infrastructure crisis. This is the breakthrough moment researchers have been building toward for years. For decades, the idea of a truly waterless toilet was treated as a niche solution for extreme environments, deserts, disaster zones, outer space. Now, engineering advances in waste processing, odor control, and compact system design have pushed the technology into mainstream consideration. More than 24 breakthrough waste processing technologies have been developed in just the past 10 years alone. These technologies are now being licensed to companies for testing, production, and real-world deployment. What was once theoretical is becoming an industry, and that industry is growing faster than most people realize. Investment from major foundations, universities, and private companies has turned toilet engineering into one of the more quietly competitive fields in sanitation science. At the same time, a completely different kind of toilet innovation has been emerging, one focused not on eliminating water, but on eliminating ignorance about our own health. At the 2026 Consumer Electronics Show, companies unveiled toilets equipped with built-in health sensors. One system, recognized as an official innovation honoree, includes a urine analysis sensor that displays health data on a connected wall monitor. Another device uses an AI system to detect if an elderly person hasn't used the bathroom in over 12 hours, automatically alerting family members. For families caring for aging parents from a distance, that kind of quiet, passive alert could make a meaningful difference. Suddenly, the bathroom isn't just a place for hygiene, it's becoming a quiet, constant health checkpoint. Separately, wellness companies have begun releasing clip-on devices that attach to any existing toilet, using optical sensors to analyze urine for multiple wellness markers, no test strips, no lab visits, just passive, everyday health monitoring built into a fixture you already use. Two very different revolutions, one solving a water crisis, the other solving a health data gap, are converging on the exact same object. It raises a strange thought. The most old-fashioned object in your house might soon be its most advanced piece of technology. But here's where the story has to slow down because innovation like this rarely comes without serious trade-offs. Waterless systems like the iPhone still face a major hurdle: cultural resistance. Toilets have been tied to water for so long that many people are hesitant to trust a system that looks and functions so differently. There's also the challenge of maintenance. Waterless systems still require regular servicing to safely process and remove waste material. In areas without reliable service infrastructure, the maintenance requirement could limit how widely the technology can actually spread. Cost is another obstacle. Even though these systems could save money on water and sewer infrastructure long-term, the upfront investment for advanced units remains a barrier for many households and municipalities. Scaling manufacturing to bring prices down is still a work in progress for most companies in this space. And for the AI-powered smart toilets emerging in the health tech space, there are real questions about data privacy. If a toilet is constantly analyzing your biological data, who owns that information and how securely is it stored? Regulatory frameworks for this kind of intimate health data are still being developed, and researchers acknowledge there's work to do before these systems reach mass adoption. There's also a technical limitation worth mentioning. Sensor accuracy in early smart toilet models still needs further validation against clinical-grade testing. Engineers are candid that these devices are meant to flag potential concerns, not replace an actual medical diagnosis. None of this means the technology will fail. But it does mean the transformation won't happen overnight. So where does this leave us? Right now, waterless and smart sanitation systems exist in a strange in-between state, proven enough to deploy, but not yet common enough to feel normal. Researchers at Georgia Tech and other institutions continue testing new waste processing methods, aiming to make these systems more affordable and easier to maintain. Engineers working on health-integrated toilets are refining sensor accuracy and expanding the range of conditions they can detect. If these efforts succeed, the next decade could bring a bathroom fixture that does more than we ever expected from something so ordinary. Imagine a toilet that requires no water, connects to no sewer line, and could be installed almost anywhere on the planet. Now imagine that same toilet quietly monitoring your health, alerting your family if something seems wrong, long before you'd notice it yourself. That's not a distant science fiction scenario. Pieces of that future are already being tested in real homes today. The technology could expand fastest in regions currently underserved by traditional plumbing, both in the US and around the world. But it may also quietly reshape how developed nations think about aging infrastructure they've relied on for a century. Because the truth is, the sewer systems most of us take for granted were never built to last forever. Many were constructed generations ago, and engineers have long warned that replacing them at scale will eventually become unavoidable. At some point, someone has to decide what replaces them. And it's possible that decision has already been made, just not by policymakers or city planners. It may have been made by a NASA engineer thinking about astronauts, who accidentally solved a problem for the rest of us. That's often how the biggest shifts in engineering happen, quietly, in a lab solving one problem, while solving another no one had connected yet. For over 100 years, the toilet was one of the few pieces of technology we assumed would never change. Now it's becoming a case study in how even the most overlooked inventions can be completely reimagined. Water, pipes, sewers, the entire hidden system behind something so basic is being questioned for the first time in generations. And maybe that's the real lesson hiding inside this story. The biggest breakthroughs don't always come from chasing something new. Sometimes they come from looking at something we assumed was finished and asking one simple question: what if we started over? The toilet may be one of the last things you'd expect to define the future of technology. But right now, in labs, in rural homes, and in space-inspired engineering, that future is already being built. Every household that adopts one of these systems becomes a small, real-world test of an idea that started with astronauts. And every data point from those homes brings engineers closer to a version that could work almost anywhere. It's easy to overlook how much trial and error stands behind something that finally looks simple. Behind every one of those 20,000 installations is a long history of failed prototypes, redesigns, and quiet persistence. That's the part of innovation stories that rarely gets told, the years of nothing working before something finally does. And the next time you walk into a bathroom, you might be standing closer to the edge of that future than you realize. Because sometimes the most powerful innovations aren't the ones that shout for attention. They're the ones that quietly wait until the whole world is finally ready to flush the old way of thinking away. So the next time someone tells you an idea is too basic, too old, or too settled to ever change, remember the toilet, the one piece of technology everyone assumed was finished. It took a space engineer, a global sanitation crisis, and a decade of quiet research to prove otherwise. And it may take just one more decade before that quiet revolution becomes something the whole world simply takes for granted. Because that's often how history works. The biggest changes rarely announce themselves loudly. They arrive quietly, get tested in a few homes, in a few countries, by a few people willing to try something new. And only later does the rest of the world realize how much had already changed. Right now, that quiet shift is happening in bathrooms most of us will never see. In rural American homes without reliable sewer access. In communities across Uganda and Panama, where clean sanitation was never guaranteed. And in research labs, where engineers are still asking whether a technology built for space could someday become the new global standard on Earth. No one